So now we need to really understand that how we gonna determine this multi-label problem, right? So now this is the problem which we have to solve, multi-label. How we solve it using my models? That's a question for us. Now the thing is that can we somehow convert it to either a binary classification problem, or if we can somehow convert this to multi-class problem. If I can somehow do this conversion, then it will make my life simple. But the question is how we can do this sort of thing. Now, in order to do that, there are a lot of articles you will find across internet, but this is one of the article from Analytics Vidya, which I love it personally. And I love it because they have basically kind of created a lot of nice diagrams, which is a lot easy for us to understand. That's the whole reason why I'm basically going to use Analytics Vidya in this case. And if you go through them, actually, they write a lot of nice blogs. I kind of love reading them, to be frank. So I would also suggest you can read more in detail on this. So let me explain you what are the techniques what we do have to solve this. Number one is binary relevance technique. Let me explain you what is being done. In fact, this is the most popular technique which is used, and also it's also called as one versus rest. One versus rest. And the idea behind this is, let's say if we have data, so let's say I have 5 rows. These are rows. Okay, I have 5 rows, and these are tags. Okay, so now what we are doing is we are putting the data for it. Let me give you an explanation for this. What exactly this is doing? Let's say I have a question Q1. Okay, which have, let's say, a tag T1 comma T2. Let's say I have a question Q2 which have the tags, let's say, T2 comma T3. I have a question Q3 which have the tag, let's say, T1 comma T4. Let's say this is my tags. Now in this case, if I look at it, how many total tags I have? T1, T2, T3, T4. Let's say these are the 3 questions. Let's assume that these are my rows where I have the data. So now in this case, what I'm gonna do, for the first one, I will create basically 3 columns. Okay. So let's say this is column T1, this is column T2, this is column T3, and this is column T4. Now I'm going to keep the data here. So let's say in this case I have T1, yes, I have T1. I have T2, yes, I have T2. This will be 0. This is not there, right? So let me do it for the same thing for this. So T1, T2, T3, T4. So this is going to be 0, 1, 1, 0. Let's do the same thing here. So in this case, 1, 0, 0, 1. Like this, I can arrange my data and keep up all these things into the column wise. So that is what being done here. Okay, this is the data representation here. So you can think of this y1, y2, y3, y4 as, let's say, tags, okay, which we had in our question. So now in this case, maybe the first row point, I have maybe y2, y3 available. In the second row, I might have only y1 available. In third row, maybe I have only y2 available. In fourth row, I might have only y1 and y4 available. And in fifth row, I might have only y4 available. So this is my way of representing it. Now, what I'm going to do with this, I'm going to split this data into this format. So what I'm going to do, I'm going to divide it into 4 parts because I have 4 different columns. So for each of this value, I'm going to repeat it 4 times. So like I'm create one with x with y1, then I will create x with y2 with this row, then I will create x with y3 with this row, then I will have x with y4. Now, if you look at it, now what basically it means, I can basically create 4 different models and then basically can work on them, right? Because now if you look at it, it becomes like a binary classification problem for me, right? So that's what we can do with this, but there's a challenge here. Remember, in our problem statement, we have 40k tags, right? Now 40, to do it for 42k tags, building 42k models is going to be almost very complicated, right? Because this is equivalent to, if you have a smaller data, smaller set of these set values, then it works pretty good. And in few cases actually do not even work well. Let me tell you, in our problem statement, when we tried actually using it, it failed for some reason, and then we have to put some sort of different logic to get this done. I will explain you at that time why it failed, because actually we will have a very sparse data. Anyway, we will explain that at that later point. But this is basically going to be like very rigorous in terms of creating number of models. And to do this, it's quite simple. So to do this, we do have, just like we have a scikit learn package, similarly we also have a scikit sk multi learn package. Okay, that is also another package what we have. And in this we do have something called as binary relevance class, and we can just pass it on here, and you can see the remaining code is very simple. So it will just take care of everything for you and get the results done for you. So this is a very simple way of working on this part. Now the second thing is, you can see the second method. This is called as classifier chain. This is in fact interesting way. So basically here again the data set is same, but what we are doing is, so let's say the first one what we got is from x1 we got, let's say, 0. So we have pulled up only this much. But for the second one what we are doing, we are taking these two as my input point, and then we are predicting for the last one. Then after that we are kind of creating a chain here. Okay, so we are like one model, we got the output, then we take the output as the input for the second one, and then we move on. Definitely this is not helping us with the last problem what we had earlier with the binary one. So definitely here also we are creating a lot of models in this case, but at the same time this is sometime useful. Let me tell you where this is going to be useful. So when, let's say, in whenever we have a situation like, if one kind of tag is having a dependency on another tag, for example, let's say this y1 is c, okay, or c++. So let's say if there's a question on c, there's a high chance that maybe the question might be related to pointers. So because generally the questions on c, if you look at in Stack Overflow also, you will notice that most of the questions will be related to pointers in that case. So that is what basically is being explained in this case, that maybe you can have a chain in that case to get that kind of dependency along with it. So this is also quite simple to be done. So if you look at this, again, we do have same package, scikit multi-learn package. And here also we can just use classifier chain and get this done. It's quite simple to do it in the programmatic format. Now, after this, we have something called as label power. This is quite an interesting idea, in fact. So here what we kind of do is, so let's say you can see this part, like this is one part, right? Now I will give, like, whenever the value is, let's say, coming as 0 1 1 0, I'm gonna give it a number, let's say 1. Okay, think of it like a pattern which I'm giving it the number 1. So I'm basically writing it up. X1, I have given the number 1 to it. Now let's look at this. This pattern is different from the first pattern, right? So I will give it a number 2. So let's give it a number 2. Okay. So now let's look at the third one. This is a different pattern from above both two. So let's give it a number 3. So I've written down here also as number 3. Let's look at the fourth part. Now this is exactly same with pattern 1, 0 1 1 0. So I will keep the name same number 1 for it. So I will give the same number 1 for it. Okay. Now let's look at this. This is different. So let's give it a number 4. Let's look at this. This is again similar to my 3. So I will give again the number 3. So now if you look at it, this becomes my multi-class classification problem. Now this looks good, but there can be still a problem with this. Problem is, if this columns are going to increase, then in that case the number of unique values are going to also increase, right? Now in that case we can end up with problems, right? Because it may be possible that we have lot of multi-class problem. Maybe I have 1 to 100 of different multi-class problem coming up, and maybe few of them are only occurring once, only one. So basically there will be very less amount of data for them to be trained on. So that can be a big problem in this case. So definitely we would not, this is not being too much used, especially wherever the uniqueness will be there, means there are too many of the set values too huge. Then again we can end up with a lot of issues. Fourth one is, and again using this is very simple. Again you can see that we can just use label power set, and we are again using it from scikit multi-learn package, and this is going to give us the result. Now there is one interesting approach which is called as adaptive algorithm. What is adaptive algorithm? Adaptive algorithm is like basically where you can change your corresponding algorithm itself. For example, let's say I have a KNN algorithm, right? K nearest neighbor. I can convert it by using ML KNN. So there can be a different algorithm which takes care of label class values. And the way it works is, you can think of it something like this. So let me draw a diagram for you to make things more clear. So maybe let's say you have a query point xq here. Now let's say this is being surrounded by x1, x2, maybe x3 and x4 and so on. Let's say now we have tags being attached to it. So let's say x1 have tag like t1, t2, t3. Let's say x2 have tags like t1, t2, t4. And similarly, we have tags like T1, T5, T6. Let's add another tag to it. Let's say X4 have tag like T1, T3, T5, right? Now if I have to compute it for XQ, so one way to think of for XQ would be like T1 is occurring in almost all my nearby neighbors. So definitely I can be assured that XQ will have a tag also T1. But if you look at, let's say let's say here I have not T5 but T7. Now T7 is not occurring anywhere nearby, so I would not put T7 in this case. Now I can look at T2. Maybe T2 is also occurring, or T3 is also occurring like 2-3 times. So I can maybe put T2, T3 like that. So in this case, what I'm basically doing is I'm looking at all the tags and then basically saying that which are the tags which are more in number near to me, and maybe we can decide some sort of rule that if let's say I have three or more than three tags near to me, I will choose it, otherwise I will reject it. Like T7 was occurring only once, I have rejected it. T1 was occurring 4 times, I accepted it, right? So like that I can put some strategy, and based on that I can do it. So this is basically a nice way of getting this particularly done. Okay, so this is the algorithm way, that how you can work with your algorithm and get this particular part.